Hi Year 10s, in this video we're looking at a concept called the y-intercept. And if we think of our x and y axis as we've got drawn over here, the y-intercept is simply the point where our graph crosses the y-axis. And it can be quite interesting to us depending on what our graph is about. And so here we have a definition of the y-intercept, and it says that if you have a line y equals x plus c, then c is the y-intercept. So if we look at these examples below, it's asking us to write down the y-intercept for each of these. So for A, our y-intercept is that number being added to x. So our y-intercept, I'll just write y-int equals positive 1. And for question B, our y-intercept is that number there, which is negative 2. So for question B, our y-intercept is negative 2. Now, we're going to draw these as well, so I'll just draw up a set of axes. Okay, so there's my set of axes. And so let's have a go at doing question A, this one here. So I'll start with the y-intercept, which it says is 1, and so that's not what I wanted to do. Okay, let's try that again. So we'll start with our, why is it stuck on the, there we go. So 1 is our y-intercept, and then because we've got no number in front of x, that means that our gradient is simply 1 over 1. So rise 1, run 1, rise 1, run 1. And that pattern will follow backwards as well. So whenever you've got a graph with just x in it, that's what it's going to look like. And so there's our line for y equals x plus 1. Okay, so for number 2, or question B, our y-intercept is negative 2. So we plot our first point at negative 2. And then once again, this has just x by itself, which means it's rise over 1. Rise over run is 1 over 1. So up 1 across 1, up 1 across 1, up 1 across 1. And then we can draw that line in. So let's just try that again. There we go. And that's our graph y, if it will let us draw, y equals x minus 2. Okay, so that's what the y-intercept is. It's simply the number that gets added on to your graph at the end, and that's often a great place to start when you're drawing these graphs. So have a go at exercise 13.07, please.